Yeah, so over here. So where did we end? Somewhere here, yeah? So yeah, so once we know the breaker, if you go, yeah, control circuit, you see this FB, zoom it in, FB30, 3.18. So if you go FB, yeah, FB30, this one here. So it means that that breaker is feeding this circuit, and this FB10 2.3G, it means that FB10 is specifically for the motor. FB10, there you go. So this is the spring charge for the breaker. So it has a separate breaker. So from there you will know, if you read this from left to right, you apply that drawing convention from left to right and top to bottom. You see this dot over here, it's a terminal block number. So 1, 2, 3, 4, 5, 6, and you can see that terminal block number sitting to each other. And it means that this K21 here originally came from this one here. And then when you go K21 or K21, this one here. K21, that one is K21. And sometimes you can see there is a bridge, you know, I don't have the photo of the terminal block, but normally they bridge this. It means that this K21 is looped in the terminal strip from 1 to 9, because that is your positive one for the DC. And at the bottom is bridge as well in this group of terminal, and it feeding this specific circuit. So now if you apply from left to right, and again, when you read this one, what is the main rules? You have to read it at de-energized state. Is it? Remember? De-energized state. So it means that the breaker is open. So now, at this specific position of your contact, like this one, and this one here, and this one here, is all de-energized. So once you switch on this specific breaker for that circuit, it means that your DC supply will be, this one will become live. And this one is become live as well. So now, if that one is become live, which one is closed? You have to look at this one here. So which circuit path will be completed then? So this one, that one is closed. So this indicator will be activated. So what's that? The CB status. CB status is open because all the position of the breaker, even the controls and the main breaker, should be treated as open. So it means that this contact will indicate open position for the breaker, for the pilot lamp. Okay? And since open, so in your edge switch, which is open, you know, because you know once you close the edge switch, that's the time that this one will move. So that's how you read it. And this one was this blocking, trap blocking indication. So this is an interlock from another panel, which is from the bus panel. This is your interlock for, you know, when you rock in the breaker?
Yeah.
When you rock in the breaker, there is a solenoid that if you don't energize the solenoid, it won't allow you to rock in the breaker. So you counter that normally. So this is from another panel that is waiting for a signal from another panel for you to allow to activate this specific solenoid. This is KA1. So you see the KA1. Normally it will tell you which contact will be going. And also this closed circuit interlock. It means that it won't allow you to close the breaker if this is open. So when is the time that the one will be open? So you have the lockout relay LR1. So your LR1 is LR1 This one here. This is your LR1. So trip latching relay. So if you go to AR5, so all this label here, it has its identification. Normally this one is from the relay. If it latch, it means that the fault is not clear. This one will close. CO5, CO3, this is from the relay. And this one will activate. When this coil energizes, it means that that contact will move. Once that one open, now you cannot close the breaker. Why? Because you need to clear the fault from the relay. So that's how you read now the schematic. From the energized state, and once there's a fault, if this is a relay, this one will move. And what else? This is the phase indicator. This is the one on that specific capacitor divider thing. And if you test the relay, when you test now, let's go to the test. That's the basic one. If you want to have the copy with this one, then you can try to interpret it, the sequence of operation. So now this is if you look at this specific part here, local, remote, and remote SCADA. So it means that if you are local, your selector switch will be here. So you can operate the selector switch close, normal, open, because this one will be, this contact will be closed. And if you remote panel, this contact will, this connection will be closed. So your remote panel, a signal from the remote panel or SCADA or whatever, if you connect that one there, you can close the breaker remotely. So you have a 3 position. Remote panel, local SCADA. Normally this is a remote panel when they do the switching, sometimes outside the room. But there is a little panel there, they call this a mimic panel, something. So they use that one. For the SCADA, this one will be, if you select SCADA, this circuit will be used. So this is specific relay as well. This is from the relay. All the contacts will be controlled by communication. So normally when we do the testing, we put it in local. So we put the selector in local, and then we can use the selector switch for closing and opening the circuit. Opening the circuit. This is the one here. Yeah, this one here. So it just bridge. So once you twist the selector switch, this is a center off. Normal when you release it, the selector switch will stay in the middle, so that when you close it, the other one will be energized, closing coil, and you go to the coil of the breaker. This is the circuit, internal circuit of the breaker. And also if you select on the other side open, this one will energize, and this is the tripping coil of the breaker. So that's how you read it. If there is no movement, it means that it's all open position. So this is a momentary signal in a way. Any question? Because when we do the testing, again, if the switchboard is designed for IP4X, so it means that they allow some kind of test block for you to test. So sometimes we go to the terminal, but if you look at this TB1, so let's go back to the legend of that thing, TB1. I know it's a test block, but I'm going to show you this one here, TB1 test block. So the test block is, I'll show you in my slide. The other one. Hang on, I have to find the one. The first one is one here. So the test block will be, looks like this. This one here. That one there. So it means no need for you to connect your test leads inside the CT-Link, because this test block will serve as your connecting point when you do the testing. Once you plug it in, you can inject your voltage and current over there, and the contact is somewhere here. You have to find that from the schematic. You have to identify that from the schematic. So the moment this one is, I think this is a overcurrent protection. We inject three-phase current, and that one is bridge there. See that bridge there? That is going to the CT, but on this side, on the black side, we'll inject straight to the relay. And this is the trip lockout, the one that we need to reset. That's why it won't allow you to close the breaker, because it's latching, So that's how it looks like. So if we go back to the drawing. Where's that one? Yeah. If we go back to the drawing, that's black there. Once I plug it in, because that one is removable, and I connect my injection point. So this one will, if you remove that test block, this one is just have a continuity. 1 and 2 will be bridge, and 4 and 3 will be bridge. What else? Because this is your trip. So normally we put the trip time contact to measure the trip time, number 2, and in number 4, because I want to measure this contacts from the relay. So no need for me to go to find this this is the inside of the inside of the breaker. This one here. Oops. No, that one there. So normally, if you don't have this test block, I mean, some of the older switchboard, they never allocate some kind of specific. I mean, they never consider the maintenance. So for economy, sometimes this one costs maybe $180 each. If you have 20 panels, so it costs $1,000. So sometimes they said, I don't want that in my design. Just remove that one. So we normally do straight wire here to remove that one. So if that's the case, there is no provision for the test block. We have to connect our here. Sorry, this one here, 321, and the other one here, and connect it to our Omicron or double to measure the speed when you do the trip test. But since this has a what you call this, a test block, this one here, and that one, that's the test block. So you have to plug in the test block, and in terminal number 2 of the test block, you can put that one number 2 and number 4. When the relay trips, then it will go straight to your injection wise. This is the relay as well. If you look at this, this is ECL 751A. So it means that if you look at on top, so this is the status, the input status of the breaker. So this input sometimes can be seen in SCADA, because the SCADA will communicate to this. Whatever input was fed to the relay, it will see that remotely. Like for example, on the SCADA people, they can see, the breaker is open because this contact is fed to the input of the relay, A10 and A11. This one, rack in or test position, that one will register as well there, earth switch. So everything is monitored through the relay, TCS. And also if you go here, this is remote racking in. Yeah. So it means that sometimes we manually rack in the breaker, but for this project, I remember we allow for remote rack in. And this controller here will make the racking in position by this motor for you to do remote racking in for the breaker from test position to rack in position. And it monitors as well the track position of the breaker. So reset, remote racking in as well. So same, local, remote, and SCADA. So that's how they do it. Depends on the selector switch that you put in the panel. And if you go down, this is the spare contacts. Means this is the spare limit switch or contacts from the breaker. QB is the breaker. So you see that specific letter over there. It designate What contact is that? Coming from where?
Is that from the auxiliary plugs?
Aye?
That's from the auxiliary
Yeah.
plug, right?
So the auxiliary plug, sometimes they wire it. It means,
Yeah, that's
the
right.
auxiliary plug, this one.
Downstairs.
And if you want the normally open to monitor, I'm going to go in this terminal X5-2
Yeah.
and X5-1. Then I can monitor if the spring is charged or not. You know? So it depends. There's a provision if they want to monitor more status, they're going to pick this up. You know? So it all wired in this specific terminal. Sometimes you see some blank over there on the terminal. That's the purpose of that. They wired all the limit switch there, or the auxiliary switch. What else? This one here. We go to the CT. This is the VT. You see the VT? From left to the right panel, you have they call this control bus. It means this is the bus for the VT, the red, white, blue, and neutral. So if you see FB86, it's three-phase. If you are experienced enough, you can see which one is the three-phase. I assume that is the VT, but it's always advisable to check or verify it on the schematic. It's not hard, rather than assuming this is three-phase, this is for the VT. You don't know if that one fit to the metering or the relay. So if you look at this one, normally when we test the relay, you inject voltage and current. So to find the terminal of your voltage injection, this is the terminal of the relay, AR501 ACL. So before he went there, the connection, it went to the test block again. You notice that? This test block here. This is the test block. So if you plug in the test block, even though you don't close this breaker, right? For example, there's another loop here going to the metering relay. So if you want that metering still receiving the signal to read the voltage, you can leave that open. You can leave that closed, but when you plug in the test block, you can test now because you can inject on the test block terminal 5, 8, 10, and your neutral is 12, and that one will be fed to your relay. So when you plug it in, that's it. It's handy to have this test block, but also it's handy and it's good for you to know how to read it because it's very important. And keep in mind that on your 5, 7, and 8 and 11 on this side, if you never switch this off, it's live. So you have to open that one, but there's some cases that sometimes internal people who do the maintenance in some of the thing that they want to try this sequence, allow this one to feed another relay, another meter. So they just use the test block, plug it in, and they want to inject here just to see the display of this one and the display of the other one. For some reason, it's part of testing. It's handy to have that one. And also for what's the other one here? Yeah, this is the capacitive indicator. That is the VT, in where you inject your voltage. Now this is the CT. Okay? So this is the CT. So if you look at this one here, I think I have it in my slide. Yeah. So if you look at this one here, again, you have the test block. So when you plug it in, on the test block, you see the shorted, bridge on this side. You can bridge it here because this is your CT link. But, you can bridge as well in because the CT needs to be bridged. Even though it's it's de-energized, but for good practice you have to bridge that one. This open link here, open link is this one here. So if you undo this, loosen this one and drop that, now you bridge the CT. This one as well. So C10 and C11, so that's the guy over there. C30, C31, that's the guy over there, and so on. So it means that this is CT1, CT2, and phase 3. So If you want to bridge them, bridge them. We use this normally if we high path the board. Testing as well, it's better to bridge them. And that's what we do. So close that one, and you see this one here?
One,
Yeah. So you open that one, and slide it down, and you totally disconnect it here. That if you don't have this test block. So that's what you're gonna do, because you have to isolate your CT in where you bridge, and isolate your relay as well, and then you can inject. So if you look at the CT1, CT2, the equivalent of that is this. Oops, this one here. So this is your CT in the terminal block of your, terminals of your ECL, and this is your VT. So EO1, AO2, so it's somewhere here. Voltage, this one here, AO1, AO2, AO3, AO1, AO2, AO3.
Voltage.
So that's your voltage, and this is your current. So yeah.
So we just have to get to reinstate in normal operation
Yeah.
to open the links, right?
Yeah, normal operation.
Just have to get to.
Yeah, if you forgot to. That's the thing, that's the one yeah, some people who do this one, you know.
Yeah,
They
that's bridge.
leave the bridge and then you energize.
And energize.
You don't have protection.
Yes, exactly.
You know, you don't have protection because you're preventing the current flow
Current
going
flow,
to the protection
The
relay.
relay.
That's right.
So the protection relay will not do its job because you forgot to reinstate the. That's why this is where we document everything: the as found and the as left. If your as found is bridged that one, then you have to report straight away.
Yeah.
If you don't know what is the consequence of that, don't worry about it. That's the as found, I leave it as left. No, but if that's the CT and it's working and they bridge that one, there's something wrong. You know. So this is the physical photo of that. If you look that on the compartment, but the equivalent of that in the schematic is this. So basically, you have to identify it properly here. So again, it's bridge here because that's the neutral or the Y connection. And again, Z01, Z03. So it's the one Z01, Z03, Z04. So all of this small letter or designation has its own meaning. They never put that in the schematic without this specific importance, you know. Of course, letter E is just voltage, understandably, you know. So, yeah, so once you insert the test plug, let's forget about the CT link. That is the CT link. Like, for example, some of the design, they don't have this test block, so it's connected straight to the relay. But at this specific design, they allow a test block, so don't worry about that one. Once you bridge this 21, 23, 25, and this 29 on the test block, and you plug the test block in, this automatically bridge the CT without in danger of, you know, touching this one. Because once you touch this one and you forgot, now your protection will not help you. It will be some catastrophic effect to the board. So once you plug it in, this one is bridged, CT is shorted, and you can inject from your test equipment 21, 24, 26, and test the relay. So you have the voltage connection, and you have, this is your voltage connection, that's very important. And you also identify your trip contact to be monitored. This one here. This one here. So I want to check if that contact is really tripping. You know? But if the relay use another contact, it's better to monitor the rest as well. Other contact that has been used by intertrip or, you know. And this is your inputs. Any question about the schematic? Any question? So this is spare output. And what else? CT, and this is the internal of the breaker. This is the one that they put that on the schematic. I mean, on the wiring.
Inside the breaker, right? This one.
Yeah, this is inside the breaker. So yeah, for the breaker tester, of course, This is specific terminal if you want to do some breaker timing. So this is the right terminal to, to connect your timing test, your spring charge motor. So normally you look at on the internet what is the brand, what is the model. So you have to go there if you want to test the breaker, because you need to find your closing coil and opening coil. So that this one is incorporated to this schematic as well. That one is here now. Yeah, that one there. See, they put it there. So just a puzzle, put them together to create a design. So I think it's okay for that one. Let's go here. So that's the physical. This is the equivalent of schematic. This is the relay. So sometimes, yeah, you see some people testing, sometimes the schematic is not available. So they switch off the relay and they connect straight away here. They disconnect this instead of using the CT link. They have the relay manual. They connect straight here for the voltage and current. That one is okay, but it's not advisable. It's not a proper way of doing maintenance, because as much as possible, I don't want to undo any terminal there, especially if the relay is old. If you manage to worn out, the screw, and then it's another issue. So anyway, what else? Maybe I'll try this one. I don't know if I have it open. So CT introduction.
The function of a current transformer, or CT, is to take a current flowing through a wire or cable.
This is the basic explanation, I reckon.
That a protective relay can measure. A primary characteristic of CTs is their conversion ratio. In this example, our conversion ratio is 100 to 5, meaning that if 100 amps are passed through the primary phase wire, the CT will scale this down to 5 amps and direct it to the relay via the secondary windings. The 5 amp measure is known as the secondary nominal current. If a fault were to occur on this phase that increases the primary current to 200 amps, then 10 amps would be passed to the relay through the secondary winding.
Now imagine if you have a CT link here. You touch that one and you leave it bridge. So the relay will not do its job, because hey, I don't receive any fault because you bridged it. No, because it's relying on that CT link. So you need to understand the S-bound. If that one is, you found that it's bridged, then you have to report it straight away. It's a red flag.
Consistent with the.
So we go now to this specific load flow, because sometimes when you test the relay, you need to understand the load flow as well. It's very, very important. So can you see this specific single line? So you have a bus, double bus. You have the bus tie, and they feed a common bus going here. The load, of course, if this is motor or another substation, all the current is going down, isn't it?
Yep.
Is it? All going down. All going down. So this one has its own CT, 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 CT. Now I put some kind of scenario. What if I have a fault over here? So which breaker, which relay will pick up the fault?
Both of them.
Which one?
No, right one. Right, right next to the green color.
Which one? This one or this one?
No.
This one?
So yeah.
This which
So
one?
both of them. They both will trip.
Okay, this one will pick up, and this one.
Is that a circuit breaker or the X is the circuit breaker?
This X is circuit breaker.
Yeah.
So after that one, you have the CT and you have the relay, CT relay, CT relay, CT relay. So if there is, I don't know how many meters this one, but it feed another breaker, maybe remotely, or there's another cable because you have the transformer. So if I have a fault in this cable,
Then one will trip.
so which one will trip?
No.
The left or the right?
Left. I think
Right.
both.
Okay. Well, just there's no wrong or right answer. Yeah.
Left one.
Right?
Left.
Left. Okay. Left.
Supply.
Right. Now it depends.
The right one pick up a spark.
Could
Maybe
be.
left one first and the
Right.
right one for a backup.
Which one? Which one first? This one?
Left one,
That one?
yeah,
And this one?
and right one has for a backup. So both will trip, but
Yeah.
the left one is the main one,
Okay.
and then right one has a backup.
Why is that? Any?
The load's coming through that breaker first.
Yeah.
So you want to cut it off before it gets to the
Yeah.
fault.
Can be a feedback coming back from the.
Yep. So yeah, there's no right or wrong. It all can be happen. It could trip or it will not trip. It depends on the activated protection on this relay. You know, because this fault, if you have fault here, this CT is blind to this fault because the fault is here. This CT can pick that up because, you know, remember, you know, in my previous presentation that all the fault will go back to its source. It's like a vacuum, you know, it will go back if the source is here. If the source is here, so I mean, there's a contribution of fault here, but the magnitude of the fault will be going back there. So definitely only small amount, but if you cut off the power here and it tends to go back to the source, definitely this one will see it. But again, there's a possibility, that's why I said it depends on the activated protection. Because remember, you have another source here. You know? So if there is a fault over there and your bus bar, your bus tie is closed, you know, this one will, it's like a vacuum, it will suck all the energy on this side here. It will suck all the energy. Since you have another feed here, so it will suck the energy going back there as well. Will loop over there. But the first one that will, you know, will trip is this one because the amount of magnitude will be picked up by the CT. And this one is only some kind of backfeed fault because of this main bus here, and you have a source here. So it will suck as well. It's like a vacuum. Imagine that if you have fault in this, there's a vacuum. So definitely the CT will see something, isn't it? Is it? So that's the scenario here. Maybe go back here. I delete one. So yeah, there's a backfeed. Now, if there is a backfeed, it depends again on the protection that you have here. Because if you have fault there, some of the load, like you have motor here, will contribute going back and go on that specific area because it's like a vacuum. Again, that's what I've said. It's like a vacuum. It will zap all the energy. And the thing is, there is a protection that if this only overcurrent, the normal one, this relay is looking at this flow. You know, that's overcurrent. But the flow of current backwards, the relay, based on its function, is not able to detect that because you need a directional overcurrent. Have you heard any directional overcurrent? So, like for example, if that one is like a vacuum, that's why you see some protection relay on site. If they have this kind of setup, then you will expect some kind of directional protection will be activated because in a common feeder, the directional protection is not activated because they don't have this kind of scenario. But if you have this, both of them are looped and there is a backfeed going there. Of course, the fault here is too big compared to this one because it's only a backfeed. Now you have to activate, I cannot scroll it down, but I have to remove this. Yeah. Remove this one. Yeah, so now you see sometimes they allocate overcurrent 100%, but 50% of the directional overcurrent. So this is more sensitive, but the directional will not trip, only 50% of 1 amps, maybe 0.5 amps, and the one is 1 amps, is looking at the normal current flow going there, that's 100%. But 50% of that, or 0.5, directional, the current will go back there because of the fault. That's the time that your directional overcurrent will trip that specific breaker. Without activating the directional, he will not detect a a backfeed current because of the fault. So you see the load flow now. If you have fault here, imagine like a vacuum that it will suck all the energy. But without activating the right protection on a specific relay, this one will not do anything because it's looking at the forward flow of the current going to the load. So if there is a backfeed like 50% of the capacity, that's the job of the directional overcurrent. So another direction, if you have a 4-quadrant, and then you can allocate the directional and it can detect that specific fault. And this is the main fault. Of course, this is the one who will first trip. But it's better to clear the fault here because you have another backfeed here. It's a double-ended comma. So that's where this directional overcurrent is activated. Any question? Because if you don't cut that off, you see the contribution of the load here. They will go there. They will go there because there is a continuous supply here.